All right, let's get to those solutions for questions 3 and 4. So for this one, we're given two different size circles, and it says use the formula for circumference to solve for pi. Let's see what that means. So formula for circumference is c equals d pi, right? Solve for pi means get that variable alone. That's what it means. Now, pi isn't really a variable, it's a constant, but we're going to solve for it like as if it were an x. Like, you know how we're always trying to get x alone? Same kind of thing here. We're going to try to get the pi alone. So we're going to use inverse operations, like undoing. Okay, so for circle A, my circumference is 18.85. So that's going to go right here. And then my diameter is 6. So that's going to go right here. So now I'm just going to plug in. So I'll have 18.85 equals 6 pi. I'm trying to get the pi alone, so I have to undo multiplication by 6. How do I undo multiplying by 6? Divide by 6. Yes. And I get that pi is approximately 3.14. All right, let's try the other circle. Same thing, c equals d pi. This time I'm going to use this number for circumference. It's going to go right here. And then for the diameter, I'm going to use 8. So again, I have to undo this, right? So I divide by 8 on both sides, and I get that pi is approximately 3.14. Okay, the second part says that we're supposed to use the the formula for area. But again, to solve for pi. We're still solving for pi, so we're still getting the pi alone. So my area formula could be written lots of ways. I'm going to write it down here. I could write pi r squared, which is normally how you see it on like formula sheets and reference sheets and stuff. But that means I could also write it as r squared pi, or I could write it as r times pi, right? Which I actually prefer the last one. So I'm going to write it like that. So I've got area equals r times pi. So for my area, I'm going to do circle A first. I've got this number down here of 28.26. That's going to go here. Then for r times r, well, I'm not given r. But if you remember that this whole thing is 6, right? But r just goes halfway across the circle. It goes from the center of the circle to the outer edge. So that's the radius. So if the whole way across, the entire way across the circle is 6, then just halfway across the circle would be half of 6. So when I plug that in here, I get 3 times 3, right? R times r, so 3 times 3 is 9. Again, same thing, get the pi alone, so I divide by 9 on both sides, and I get that pi is about 3.14. All right, one more to go. I'm going to use the same area formula, r times pi. This time for area, I'm going to use the larger circle area, which is 50.24. That gets plugged in here, right? Then for r times r, I need the radius of this circle now, right? So if the whole diameter, that's all the way across the circle, is 8, then my radius here would be half of that. And when I plug this 4 in for r, it gives me 4 times 4, which is 16. Divide by 16 on both sides. And I get that pi is approximately 3.14. No surprise, right? Wow, shocker, it's 3.14. So I'm going to let you sum up what observations you can make about the value of pi when we're doing like circumference area for these two circles. Okay, question 4 takes a little bit of back explanation to really do it justice. So let me start by saying that this is a triangular prism. It's named a triangular prism because its bases are triangles. Now that might be a surprise because you might be looking at this thinking, well, yeah, the base is the face that it's sitting on, right? It's sitting on its base, but it's not. So how do you find the bases of a prism? How do you know which two faces are the bases? It's pretty easy once you have some practice with it. Here's what you want to look for. You want to look for two faces that are parallel and congruent. Which two faces of this prism are parallel and congruent? Now, the students that I've asked this question to in the past have answered rectangles. The rectangles, they're parallel and congruent. You might have two congruent rectangles there, but they're not parallel, right? Parallel would mean that they never touch. But these rectangles touch on the top, they touch, the base touches the sides, right? They intersect in lots of places, so the rectangles are not parallel. The only two faces here that are parallel are the triangles. One's in the front, one's in the back. They're parallel. They're never going to cross. Even if we were to extend them and make them super big, they're never going to touch. They're never going to intersect. So the bases are the triangles. Okay, so the reason why I needed to say that is because the formula that I want you to use for volume is area of the base, so it's important to know what face is the base, times the height of the prism. So that brings me to my next question. What's the height of this prism? If the bases aren't what I thought they were, maybe the height isn't either. And that might be true because this prism is not standing on its base. So you can't just look at how tall it is and say that that must be the height. It's not. The height is how far away the bases are from each other. Right? So we know we've identified the triangles are the bases. How far apart are the triangles from each other? That's your height. So in this drawing, the triangles, the bases, are 20 centimeters apart. That's the height of the prism. Okay? All right, so let's do this. We need to find the area of that triangle. Here's another little back explanation before we can do this, right? So area of a triangle. How do we find area of a triangle? I've asked quite a few students this, and many of them have answered me and said length times width. But you're off to a good start if that's your answer, but that's not quite the end of it. So let's say I have this rectangle, and I'm trying to find the area of this rectangle. And so I could sit here and count, right? 1, 2, 3, 4, 5, 6, 7, but that's kind of, it takes a long time. A quicker way to find the area would be to multiply 3 by 5 because there's 5 in each row and there's 3 rows, right? I'm counting squares. So the area of this rectangle would be 15 square units, whatever unit I'm using. Okay, but now let's look at a triangle that would be drawn inside this rectangle. So let's say that this is my triangle. And I want to find the area of this triangle. Obviously, the area of this triangle is less than the area of the rectangle. It doesn't take up the whole rectangle, right? It's a lot less. But what's the relationship here? Well, if I split my triangle right here, I can see that this part that's in the triangle is half of this rectangle. I can also see that this part, which is in my triangle, is half of this rectangle. So the triangle has half the area of the rectangle. So the area for this particular triangle, I would have to do 15, right, 3 times 5, divided by 2, which would give me 7.5. So the area of this triangle is half the rectangle. So what I have to do when it's a triangle is I need to find, let me get another color here. I have to get my base of my triangle, right? That's this part. That's 5 times the height of my triangle, which is 3, and then I have to divide it by 2. Okay? So that's how you find area of a triangle. It's base times height divided by 2. Okay, let's put this all together. So where I have area of base written, I'm going to put base times height divided by 2 because that's how I'm going to find the area of the base because it's a triangle. Okay, so now we just start plugging in. So I know what the volume is. The volume is 240. So this number is going to go right here. So I'm going to have 240 equals. The next number, or actually variable that I come to is b, lowercase b. That means the base of my triangle. The base of my triangle is 6. So that goes here. I don't know h. That's what I'm looking for. So it stays a variable for now. And then I divide by 2 because triangle is always half of what a rectangle would be. And then I multiply by the height of the prism, which remember, that's how far apart the bases are. So I'm going to multiply by 20. Let's simplify this a little bit. So 6h divided by 2 is 3h. I multiply that by 20, and that's still equal to 240 over here, right? So I just simplified this part. It's 3h. Then I can multiply in any order. So I can multiply the 3 by the 20 to get 60h. And then I've got one last step, and that is to divide by 60. And that gives me that h is 4. Right? Good? Okay. So that's what I was looking for. I was looking for the height of that triangle on the base, right? But there's another part to this problem that I forgot to put on the slide because you are also asked to find the surface area. So let's do that next. To find the surface area, so this is kind of like a part B, find the surface area. And to find that, I have to find the area of each face and then add them all together. So if I look at the faces that I've got on my prism, I have 2 triangles, right? And then I've also got 3 rectangles, right? So let's look at the 2 triangles first. So we know that area of a triangle is base times height divided by 2. So the base of my triangle is 6. The height of my triangle is 4, because we just found that, divided by 2. 6 times 4 is 24. 24 divided by 2 is 12. Now, that's just one triangle, but I've got 2 of them, right? And they're identical. So if I've got 12 for the triangle that's in the front, plus 12 for the triangle that's in the back, that gives me a total of 24 square centimeters. That's for both triangles, right? Now let's look at the rectangles. Oh, and there's a bit of information that's missing here. These sides are congruent, so this side is also 5 centimeters. Okay, so now for the 3 rectangles, let's start with the rectangle that's in the bottom, where it's sitting, the rectangle that it's sitting on. That rectangle is 6 by 20. So that's 120 square centimeters. Then we've got one on the left side, and that one is 5 by 20. So that's 100. And then we've got this one left here on the right. That's the last one that we have left to do. And that one is also 5 by 20. So it's also 100 square centimeters. Let's add these rectangle areas together. We get 320, and that's also in square centimeters. So now all that's left is to add these two together. So 320 plus 24 gives me 344 square centimeters. And scene. We're done. That's it. So please, please, please let me know if you have any questions on any 4 of the DBA questions, because I want to make sure that you're solid on these, that you're confident going in when you take part 2 of the module test. And so if you're not, let me know before you take the test so I can help you before the test so that you can go in and just ace it. Easy peasy. Lemon squeezy. Bye, guys.